Okay, so how was the quiz? What does that mean? Easy, doable. You got through in 40 minutes, both approaches, both the methods. Okay, so let's talk about what were the difficulties, and I also want to do MATLAB programming of Gauss-Seidel method. And before we do that, this is a program that I wrote. We are going to write it together now. So please get your laptops out, open MATLAB. And I just want to run this program with the problem that you just did for your quiz and see the solution. Okay. So while you're opening your computers, just glance at the screen. Your equation is 5x plus y equal to 19. So 5x plus y plus 2z equal to 19. I entered those coefficients 5, 1, 2, and 19, A11, 12, 13, and B1. And what is our second equation? X plus 4y minus 2z equal to minus 2. Okay, so I also entered that 1, 4, minus 2, minus 2. Okay, is this nomenclature making sense to you? The way we call it A11, A12, A23, and so on. Okay. And then the third equation is 2x plus 3y plus 8z equal to 39. So I have 2, 3, 8, 39. I have all this and I have a program written for solving this problem. I'm just going to hit run and my program just ran. So you can see that GS class, Gauss-Seidel class just ran. I don't know the answer, so I'm going to print out my X, Y, and Z values. And I get 2, 1, and 4. Is that what you got? Or you would have done like 4 iterations in the Gauss-Seidel method. Maybe you didn't precisely get 2, 1, and 4. But if I just randomly take a sheet and see it here, you all have close to 2, close to 1, and close to 4. For the first method, Gauss elimination, you would have got this exactly 2, 1, and 4. And this module is really a giveaway because your calculators can do this problem. You would have put these equations into your calculator, gotten the answer in the first minute, and then you would have spent the next 39 minutes knowing the answer, didn't you? Your calculators can do this problem, right? So you did get the answer. You know the answer from the start. Or you could have known the answer from the start. So when I'm giving you a problem or when you are presented with a problem, you need to use all the resources you have. I'm testing you to know whether you understood the method. So if you know the answer and you use it to guide your thinking, that is a victory for me. I want you to be able to do that in real life also. If you know what is the answer and you have to work towards it, that's how life works. Okay. So in the exam, feel free to use your calculator. And if we can take it up a notch, I would want to give you word problems in the exam, let you keep your computer, run these programs, whatever programs you want, and you need to use it to solve problems if you want to go to that level of using the program. We'll see. I'll see how well we get together as a group in doing programming. And if you become good, we can do that. That is, I'll let you keep your computer for the exam. Okay, we'll see. Questions about the exam, about the quiz? You feel okay? You feel like you will be able to score well? I'll do the grading and keep you posted. Okay, so I'll give you a minute to get your MATLAB running and then we are going to build this program together. Please do that. Are you guys ready? Looks like all of you are ready. So how does Gauss-Seidel work? Where do we start? Logically speaking, what's your first step? Guessing values. Okay. So before you guess values, you need to tell the compiler what are your coefficients. right? So you need a way to enter the coefficients first. So that's what I had in this block, where I input the coefficients. Without these, it wouldn't make much sense for me to make an initial guess. Okay, so start your program. As you do with MATLAB, do CLC and clear to clear the workspace and the screen. And then you want to write enter coefficients of the equation of the system of equations Ax equal to B. And then A is nothing but you have you have A11 x plus A12 y plus A13 z equal to B1. I want you to enter these because if you're building a program, you should know what you're doing and also document what you're doing. So this is good practice, good programming practice. I mean, A21 times x, 22 times y plus 23 times z equal to B2. A31 plus A32 plus A33 times z equals B3. It's a really simple method, so please do it with me and get your own program. Are we good up to here? Okay, so now row 1, we want to write A11 is 5, A12 is 1, A13 is 2, and B1 is 19. Row 2, similarly, please enter row 2 and row 3 by yourself. Question? I don't think words is wrong. Oh yeah, I think I mixed 2 and 3. 1, 4, minus 2, minus 2. Thank you. No, at least one person is following what I'm saying. Are we good up to here? Back there? Good? Okay. Mary, how are we doing? Okay. You good? Okay. Okay. Okay, so now what's the next step? You have your coefficients. Now seems like a good time to make your initial guess, right? So you're solving for x, y, and z. So we'll say our initial guess is x equals 0, very simple guess, y equals 0, z equals 0. Okay, you made your initial guess, which is like the first row in your table. How do you set up the automation? How do you set up a solution and run it as many times as necessary until you get a converged solution? When you do this by pencil and paper, you did like a fixed number of iterations because I told you so. But how do you come up with a condition that will just tell you or take you to the solution until you need to iterate? While statement, or like you just have to keep iterating. Say it in words first. You have to keep iterating until equals or less than 0. What is equal? Until your residue is greater than your tolerance. Okay, so let's write that down in words first. Keep iterating until the residue within quotes is greater than the desired tolerance. It's very important that you write this sentence down because then the next step is just converting this into syntax. Keep iterating until the residue is greater than the desired tolerance. Okay, that's clear in your head. But how do you tell the compiler what the tolerance is and how to start this loop? How to tell the compiler? Well, you can just say the tolerance equals 1e power, say, -6. I'm just choosing that. Chosen tolerance. Okay, chosen tolerance is 1e -6. And then I'll have to say while my residue stays greater than tolerance, I'll continue the operations. Who can tell me that we are having a problem and what that problem is? We have a problem with the way I've written this. What is that? Define residue. We haven't told the compiler what residue is, but you're asking to predicate a operation based on that residue. That's a contradiction, right? That is, you have to tell the compiler what residue is, so that when it comes to line 36, it will check whether that residue is greater than or not the tolerance, which if you haven't defined, it's undefined. Okay, so before this line, you also have to say residue, let's say it is equal to 1.0. That is a dummy value to get the loop started. Because after that, the residue value will be recalculated at the end of after each iteration. So this dummy value is just to get into the while loop. How many of you are like feel you aren't that proficient in programming? Okay, so here's a tip for you. When you are a beginner, feel free to be as simple as you need to be and write these kind of notes to yourself so you remind yourself what you're doing. As time goes by, as you become more proficient, you will stop having the need to have these kind of remarks, and everything, most of it goes in your head, and you just put down only the bare minimum on your code. Don't think you should be a pro on day one. That's all I'm saying. Feel free to take baby steps and eventually you will get better. Okay. All right. What do we do inside the loop? What is the meat of this Gaussian iteration method?
Set up the equations.
You have to set up 3 equations to update x, y, and z. And then using those x values, you need to recalculate your residue. That's the 2 things, right? Step 1, set up 3 equations to calculate x, y, and z. Before I go into these 3 equations, I want to take my current values and store them as x old or x, let's say x previous is x, y previous is y, and z previous is z. I'll keep them before I kind of replace them. Okay, because that is what you need to compute your in the table you had the xi plus 1 minus xi, yi plus 1 minus yi, and zi plus 1 minus zi. That you need these to be able to calculate. Okay, so now what? X equals B1 minus A12 times Y minus A13 times Z divided by A11. Ensure A11 is not 0 when entering the coefficients. One second. Sorry, come again.
Your A1.
Oh yeah. Okay. And similarly, y equals B2 minus A21 times x minus A23 times z divided by A22. Ensure A11, A22 and A33 are not 0. And z equals B3 minus A31 times x minus A32 times y divided by A33. Are we all together? Yes. Okay. So what is the next step? You have updated your x, y, and z. Now what? Now what? Calculate your residue. Okay. So now calculate residue. And I'm just going to simplify this a little bit. Say Rx equals, I'll say absolute value of x minus x previous Ry equals absolute value of y minus y previous. Oops. And Rz equals absolute value of z minus z previous. Is there like a universal definition of a way or a way to calculate residue? Is residue kind of etched in stone, or if you look up the dictionary, there is like residue defined as this formula? Say yes or no question. No? Residue is like, it's subjective. You can define residue in many different ways. Or as I recently learned the idiom, there is more than one way to slice the salami. Right? So you can define residue in couple different ways that I can think of. Residue can be square root of rx squared plus rx squared plus ry squared plus rz squared. This is one way to define the residue as the square root of the sum of the squares of the differences. You can also say residue is the maximum of Rx, Ry, and Rz. You can say it's the maximum of Rx, Ry, and Rz. And either I will indicate something in the problem, or if I leave it to your choice, you have to clearly say which you picked and proceed. There is no one correct answer. Okay. You could be creative about this, and you can think about another way to define the residue, which you are welcome to think about. Okay. So obviously we can't have both conditions to the compiler. So we'll comment out one, and let's say we go with the first, or we can comment out the first and go with the second. Either is fine. With me? Like, does it make sense? So, okay, you have done your residue calculation. Now what remains? What else is needed to be done? Yeah. The loop, I already put the end. Remember at the start, actually nothing's left to be done. We did X previous, right? So we are good. So we're good. So you can do one thing. You can say, you can keep an iteration counter and increase it by 1 to know how many iterations you are actually going through. So when you choose your guess value, you can say iter equals 0. That is your guess. And then you can increase the iterations, and then we can do, if you want to do some plotting, okay? So, okay, I'll give you time to do it up to here, run your program and tell me if it works. Okay, I had the square syntax wrong, so it gave me some trouble, but otherwise I have iter, x, y, and z. After 11 iterations, actually I print out recipe. After 11 iterations, I get these solutions 2, 1, and 4, with residue being 9.5 times 10 power minus 7. 9.6 times 10 power minus 7. Those who are trying, I need you to tell me if you are able to get up to here. It's not a, it's just a counter. So I started at 0, and after each round of calculations, I update it by 1. So I'll say update iteration counter, just to keep track of how many iterations. Is your program working? Yes. Yes. Chuck, how about you? It's working on it. Because we have compressed everything. So if you see here in the workspace, it has all populated. And what you have done is by putting the semicolon, you have suppressed the printing. Now run it. But why are you getting, you're not getting the same numbers I'm getting? Did you enter the coefficients correctly? 1, 2, 1, 3, 2, 1, 2, 3, 3, 1, 3, 2. Seems correct. Did you enter the coefficients correctly? Check that. But your program is working. Yeah.
You know, the same problem.
Break line 59. Either we can select one error. Yeah, you unrecognized variable either. So if the compiler is telling you what the problem is, you need to go and enter a initial value for either before the loop. Before it's called upon for the first time, it has to be defined or given a value. Are we doing okay here? Yeah. Yeah. Scroll up to your code. Good. Okay, so I'm going to I'm going to post this code on the web page. Let me just show you one thing before I give you some more time to keep working on it. So I'm going to do iter array equals iter array comma iter, and then I have residue array equals residue array comma not comma space residue. These are kind of like bells and whistles. Okay, so I want to do a plot of residue versus iteration number. So I'm not adding comments. I'm assuming you will go home and look at this code again This is just MATLAB syntax, which if you know MATLAB, you will know. And then I'm going to do plot, or I'll say log plot, iter array, comma residue array, x comma y essentially. We're getting a figure. Log, it's just log. Yep. So pay attention for 1 second. Let me show you this. So on the right here, I have a plot of residue. Remember what was the initial value we gave for the residue? 1. We started the iteration with residue equals 1, right? So then we, after each iteration, that is 1 up to 11 iterations, after each iteration, the residue is plotted here. And you can see that it's quickly going below 10 power minus 6, which was our stopping criteria. Okay. So in order to make sense of this array command as well as this plotting command, how do you generally get help in MATLAB? When you're using MATLAB, you want to do something, where do you go for help? Go up there, see the question mark, MATLAB help, just type what you want to do and usually it pops up something. Okay, so I want you to go home and look into this MATLAB syntax. I don't have time right now to talk about them, but it's pretty simple. You'll figure it out. So are people still trying? Did you get your program to work? Did it do 11 iterations and give you an answer? Okay, so I need to make a few announcements. I want you to look at these and then continue your programming. So if you go to your eCourseware page, so this is fall 2024. From next lecture, we are going to discuss module 3, which is probability and statistics. I've posted 2 handouts. Please look up. This is important. I've posted 2 handouts. Part 1 is a book chapter from a textbook. I've just extracted the pages that are relevant to probability and statistics. What I want you to go through is to look at these this reading material, and I'll send out a list of terms. Maybe, or what I'll do is, along with this part 1, part 2, I'll add a file to say terms to review, like definitions to review, which I want you to read this before next Tuesday. Wait, today is Tuesday, right? Before Thursday, I'll post the list of terms today. Before Thursday, I want you to read those definitions. Just give it a read before you come to class. So data representation, histogram, what is a standard deviation, what is a mean, what is variance, and then what are experiments, what are outcomes, what is a distribution. Just read the definition once before coming to class. And then during class, I will go over those terms, and I'll also follow this second part, which I posted as a handout, which is another book chapter on probability and statistics. We will follow this closely in order for problem solving. So we'll learn what is a mean, what is a confidence interval, what is a probability distribution, normal distribution, Poisson distribution, binomial distribution, and so on. So everything that you need for this chapter is contained in this handout here. Towards the end here, you see what is called as Monte Carlo simulation. That is section 4.9, I think. So section 4.9, Monte Carlo simulation. This is something we want to do. Like, I've allocated 4 lecture periods, I think, for this probability and statistics. I want to be able to do this on the fourth lecture, which is like a programming thing we want to do. Here's the problem we are going to solve. Everybody here is following presidential politics? No? I'm shocked. Okay. So, long story short, there are like 7 swing states in which the outcome matters much more than the remaining 43 states. We know that, right? So you know what those states are. And in each state, you will see that candidate A or candidate B, they are almost tied, like 49, 51, 48, 52, and so on. So if we say that there are 7 states and we know what the percentage of for each candidate, can we, as a class, make a prediction of what is the chance of Trump winning or Harris winning in November based on those probabilities? We are going to do this scientifically. Basically, take the 7 states, assuming that the remaining 43 states are all like done and dusted. There is nothing to worry about them. In those 7 states, we are going to simulate scenarios. Suppose Trump wins 4 states, Harris wins 3 states, and it depends which states because they have all each different number of electoral college votes, right? So we are going to simulate scenarios and then run, let's say, 1,000 cases or 1,000 predictions of different possibilities for the presidential or electoral college vote. So we want to say that Harris taking the White House has X% chance, and Trump taking the White House has Y% chance based on our simulation. We are going to do this like a class project. If you all cooperate, you don't have to do homework for for module 3. Just do this programming with me. At the end of the 4th lecture, if we can run our code and get an output of a prediction, which is our prediction, if you do that code and show that code to me, submit that code, you don't have to do like a separate submission for your homework problem. Either do that with me or do your homework problem, which is kind of boring, but this problem will be much more fun to talk about. Okay, so I want you to review this section 4.9 as we go on. And also, I want you to do a couple of steps as homework. How many of you are aware of 538? The polling site, 538. No? Okay, I want you to go home, Google 538.com. Okay, Google 538.com and look at what are the polling averages for the 7 swing states which we will simulate. Do you at least know what are the 7 swing states I'm talking about? Pennsylvania, Wisconsin, Michigan, Georgia, Arizona, not Florida. There's 2 other states. I think Nevada, and what is the 7th state?
Ohio.
No. No, I think North Carolina. I think North Carolina is sort of purple, but I'll try to look into that. But I want you to do some homework into this. If you do this programming, you don't have to submit homework 3. Deal. Okay? All right. So please review these and become prepared for Thursday. Statistics is a very difficult topic, and I'm going to be covering a lot of topics within that. So you need to come really sharp, bring some coffee. Okay? Thank you. Yeah. Homework 3. You just did homework. I mean, yours. Yeah, I know. Homework 2 is based on module 2, equation solving. Homework 3 is based on probability, which you don't have to submit if you do the programming exercise and make a prediction about presidential election with me. Okay? Yeah. Can go back to my code? Yes. Yeah.
The problem with mine is diverging.
Diverging?
Yeah.
Which means you haven't arranged the coefficients like we discussed. So what are your coefficients? 5, 1, 2, 1, 4, minus 2, minus 2, 2, 3, 8, 39. So go down to your equation. Which means you could have made a mistake while entering your formula. 1 by 2x, 2, 3. Okay. I'll go to your while condition. Stop the record. Hey, can I talk to you for a second? Sure. Just give me 5 minutes, let me talk to you.